way. So we're going to use a technique called a U-substitution. The U-substitution is done to undo the chain rule. Okay? And think about that. I mean, the chain rule introduces new factors that weren't there before, making it complicated to go backwards. Okay? So the U-substitution is a methodical way of undoing the chain rule. Okay? So it is the only integration technique we're going to teach in this class beyond the elementary ones that we've done. Is it a basic antiderivative, or could I use the power rule after I rearrange it? The only other technique we get in this class is that of a U-substitution. Calc 2 picks up and starts teaching more integration techniques right off the bat. Trig substitutions, integration by parts, partial fraction decomposition, lots of other tricks that you can use. But the most common trick is still the U-substitution. It's the most common one to use. Okay? How do you know if a problem is geared up for a U-substitution? Well, what you're looking for in a U-substitution problem is an expression and the derivative of that expression up to a constant. Okay? So I'm looking in this original problem here, and I'm looking for an expression and its derivative to show up. I think I see it. I think I see this expression right here, and its derivative shows up right here. Do you see it? Okay. By the way, this showed up perfectly, meaning the constants were just as I wanted them to be. So I'm going to call that a perfect substitution. Okay? In other problems, you might have to rearrange stuff with the constants to make the substitution work a little bit better. Okay? So this is what I'd call a perfect substitution. What am I looking for? I'm looking for an expression and the derivative of that expression. So here's what we do. We go ahead and we say let u equal the expression. We let u equal x cubed minus 3x squared. Okay? Now, in math, you can replace anything you want with any symbol you want. Okay? But the problem comes in how is that symbol, or how are those expressions tied to other expressions? So I cannot just put a u here and call it good, because how am I taking the antiderivative? With respect to what variable? With respect to x. So when I do my substitution, I also have to adjust the variable that I'm taking the derivative with respect to, and that's the tricky part of the substitution. And it will be for any of your would be for other substitutions that you do in later on. Okay. So what I'm now going to do is I'm going to take du dx. I'm going to take the derivative of this expression that I just wrote. So I just wrote out this statement here, this function here. One way to look at it is I defined a new function u as an expression of x. And now I'm going to take the derivative of it. So what is du dx? 3x squared minus 6x. And it's the fact that this perfectly matches this that makes this a perfect substitution. Okay? Now, we're now going to do a little bit of manipulation symbolically, even though it's not really meaningful. I'm going to go ahead and multiply both sides by a differential x. I'm going to multiply both sides of this equation right here, both sides, by a differential x. Okay, let's do that. That gives me du is equal to 3x squared minus 6x differential x. Okay. Now, this is actually the substitution. So I was kind of hiding stuff from you a little bit, but I didn't want to talk about it until it was time. Here is the expression, and what is the derivative of the expression? This piece right here. What did I just do? I just also underlined the dx. Okay. So what am I going to replace u with? Or excuse me, what am I going to replace x cubed minus 3x squared with? U. What am I going to replace these two factors with? Du. Okay. So here we go. This is how the substitution works now. So in place of this piece right here, I'm going to write u to the 5th power. Okay. And then in place of both this factor and the dx, I'm going to substitute in a du. So we put just du here. clean that up. We write u to the 5th du. Okay? I don't expect you to get this my first pass. Usually people are very confused the first time I do this, so it's one of those situations where let me get through the first example, we'll do a couple more, and then we should start feeling a little more comfortable. Okay? So I adjusted not only the expression, now it's a u, but I also adjusted the variable of integration, which is the key part that makes this work. Okay? Put another way, the original problem had a lot of clutter in it, and I'm sort of avoiding the clutter with the letter u. It's now easier to look at this problem. I could have answered the question from here, but it's easier to look at this way. Okay? This is a change of variables to make our lives easier. Okay, let's take the antiderivative of u to the 5th. What is the antiderivative of u to the 5th? 1/6 u to the 6th. Nope.
No.
We're just finding a general antiderivative here, right? As somebody pointed out, there are no limits of integration on this. I'm not asking for an area under a curve right now. I'm just teaching you this technique. We'll do it with areas underneath the curve later. Okay? All right, this part always sounds like I've got, well, I don't have good English anyway, but this part makes me sound even worse. Okay? Am I done with this problem? I was looking for an antiderivative of some function of x, right? I've given a function of u. But u wasn't the variable you were asked to solve for, was it? Well, what was u? Well, u was 3x squared minus 6x, right? So I'm going to take the expression and replace, the phrase we use is back substitute what u stood for.
I thought u was x to the 3rd minus 3.
Oh, my bad.
Okay.
Oh, golly.
Oh.
Oh, golly. Oh. I just screwed up the punchline of the joke. We got all the way through to the end and I screwed up the punchline. Okay. Folks, I have already said this. Which is easier, taking the derivative or the antiderivative? Taking the derivative. What should you always do after you take an antiderivative? Check your work, just to be sure. I especially encourage it for U-substitution problems because in checking your work, you're going to get a better appreciation for how the U-substitution works. Okay? So, on another page, let's take the derivative of that. Or somewhere else where we've got room. I'm going to take d dx of 1/6. What was in there? It was x to the 3rd, right?
X to the 3rd minus 3x squared. All to the 6th.
To the 6th plus c. Great. So I'm going to check my work by taking the derivative of this. Okay? By the chain rule, we've got an inside function and an outside function, right? The outside function is u to the, excuse me, well, it actually is u. The outside function is something to the 6th power, right? So that will be 1/6 times 6 times that something, all now to the 5th power. But by the chain rule, I now have to multiply by the derivative of what was inside there, which gives me 3x squared minus 6x. And of course, the derivative of the constant is 0. So you see how we undid the chain rule with the U substitution.